Okay, so question 13. What are the resonance structures of the nitrate ion? Okay, so first let's draw out a Lewis structure. Let's calculate the total valence electrons of the molecule. So nitrogen has 5 valence electrons, and oxygen contains 6. And since there are 3 atoms of oxygen in the atom, we multiply this by 3. And also the molecule has an overall negative charge, so we're going to add an additional 1 electron to our total count. So this gives us 24 valence electrons. So now let's draw out a Lewis structure down here. Nitrogen will be our central atom. And let's see what happens if we draw single bonds to all of our oxygens and fill out any lone pairs that we guess it might have. So if we count out the total number of electrons of this particular structure, with each bond containing 2 electrons, you'll notice that we have a total of 26. So that means if I take out the lone pair of nitrogen and add a double bond to one of the oxygens instead, then we get this following Lewis structure. So now if we count out the total number of valence electrons, we have 24. So this is one resonance structure of NO3 minus. And to double check to see if we did it correctly, let's calculate the formal charge of all of the atoms in NO3 minus, just to see if they will sum up to equal -1, since this is the overall charge of our molecule. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Let me bring this down a bit. Okay, so the formal charge of, let's do nitrogen first. Nitrogen has 5 valence electrons, and there are no lone pairs, so there are no non-bonding electrons, so we make this 0. And there are 4 bonds to nitrogen, so this gives us a total of 8 bonding electrons divided by 2. So this tells us that our nitrogen has a +1 charge. Let's draw a positive charge on our nitrogen atom. And now let's calculate the formal charge of one of the single bonded oxygens. So oxygen has 6 valence electrons, and the single bonded oxygens contain 6 non-bonding electrons. And there's only a single bond, so we have 2 bonding electrons divided by 2. So this tells us that the formal charge of both of the single bonded oxygens is -1. So I'm also going to show that these two have a negative charge. And lastly, let's check the formal charge of the double bonded oxygen. So this is double. And it still has 6 valence electrons. And this time the number of non-bonding electrons is only 4. And it has a double bond, so there are 4 bonding electrons divided by 2. So this tells us that it has a formal charge of 0, so I don't need to write a charge on it. And if we sum up all of the formal charges of all of these atoms, then we get a total charge of -1 for this ion, which is what we wanted since it's NO3 minus. So now we can also draw resonance structures, just showing how each oxygen is able to carry this double bond, and the double bonds will kind of move around the ion. So this is if the leftmost oxygen contains the double bond. And lastly, if the rightmost oxygen contains the double bond. Okay, so these are the 3 possible resonance structures of NO3 minus. And the junior tutor said that in order to obtain the Lewis dot structure of nitrate, first solve the total number of valence electrons, which they calculated to be 24. Next is to identify the number of lone pairs that would be on the central atom. By identifying the highest multiple of 8, and that is exactly 24. Because of this, there would be no lone pair around the central nitrogen atom. That's another way of deducing what the structure may look like. And every time the oxygen has a 1 bond, it would automatically have 3 lone pairs to obey the octet rule. Now we can draw the Lewis dot structure of the nitrate ion. And since the nitrogen atom has a 1 positive charge, we have a final Lewis structure of the following. And they showed the 3 different resonance structures that you could have as well. So this solution is correct.